Okay, we're going to make a motor assembly. Where we started with a two-dimensional sketch. Started the origin. It makes a circle, right? It's just a two-dimensional circle. But I'm gonna make it of a certain size. This circle is going to be 42 millimeters. So now I have a 42 millimeter circle. But it's still two-dimensional, so I come over here and extrude it. I want it to be 17 millimeters deep. There. Now I have a cylinder boss. I'm going to go over the back. I'm going to pick a surface to draw on, so to speak. And I make a center line that goes right through the middle. And then I'm going to create a little notch. There. Now I want this to be centered on the center line, so I'm going to put this line's center point and the center line that I created, and I'm going to tell it to be coincident. And then I'm going to tell these two lines to be at a certain angle. $80 degrees. 80 degrees. And I'm going to probably make this line a little bit bigger. When I created this line, I actually hugged the outline, so now this period right here is always going to be coincident with that. It's coincident with that, with the circumference of the circle. So no matter what I do to this line, it's going to be constrained, and always keep those 80 degrees. These black lines mean that they've been defined by the sketch. So now I'm going to fill it $2mm fillet. Let's try 4 millimeters. There we go. That's pretty good. Actually, I'm gonna there we go. Now I'm gonna fill it. There. So I have a new sketch there. I'm going to extrude that one as well. In the opposite direction. And then I'm just going to make that 5 millimeters. 0.85 millimeters. Now I want this feature to be on the other side of the motor, so I'm just going to tell it to circular pattern, 180 degrees along this line. There. Now, being parametric, we can change any of the parameters. It won't let me do that. Well, that's why, because I messed up the fillet. You can change any parameter. And it's reflected in the final rebuild. Then I'm going to go back to the back. I'm going to make a new center line on this sketch. And I want this line to be centered on the against the origin. Get really close, so I choose the origin and the center of that line, and I tell it to be coincident. Now, no matter how big that line, it could be 80 millimeters, or it could be 20. It's always going to be centered, because both the origin of that circle and the center line middle are coincident on each other. But I actually want these to be 50 millimeters apart, because I'm going to use them as a basis of two new sketches. I'm going to put M3 bolts through this, so I'm going to make smart. I'm going to dimension these circles to be 3 millimeters. Again, they're just sketches on the surface, so now I can actually pick that sketch that I just made and cut it. And I can always go back here. Because that cut was only just as thick as this line, but I could tell that cut to go all the way, for example. Edit the feature. I can say I want it to be through all. But of course, that's not my design, so I'm going to come back here and make this 50. Excellent. I'm actually designing something that exists, because I'm making this motor part of an assembly for a bigger item that I'm making. So I'm going to go back to my ISO view. Coming to the circle, I'm going to make a new sketch, new center line, starting in the origin. Just make a sketch. I want this to be 10 millimeters from the center. And then I'm going to make a new sketch right here. I want to extrude that by, what was it? That should be 5.8 millimeters. And then this one, I'm going to make a new extrusion. Just make that 4 millimeters. Actually, that's incorrect. I'm going to extrude that sketch by that's 42 minus 6, 37. There, you have my motor that I'm ready to make into an assembly with my gear. So I'm going to save this. And I'm actually going to make an assembly from this part. I'm going to insert the gear that I already made the other day. Just put it anywhere. And then I'm going to mate these two components. I'm going to say that this shaft is concentric with this inner surface. Automatically picks the concentric mating. And then I want, I would accept that. And then I want this face to be parallel to this face. All I have to do is add my M3 nut in there, but I have my subassembly. It's hard to show. I don't know if I can actually put this on the video to show kind of like what this looks like. Maybe if I open Skype. So there's a little video preview thing here. Oh, Microsoft, you suck, man. There. So I can put this in my big assembly. I don't know how other pieces of software work, but SolidWorks is, for lack of a better term, pretty solid. Hope you enjoyed this little demo. I'll be making more SolidWorks videos as I get better with the software.